A very good morning I bid to the honorable panels and my supervisor, Dr. Lui. My name is Kok Rui with my matrix number 192901, and I'm going to present my final year project entitled Aluminium Oxide Coated Carbon Char as Adsorbent for the Removal of Arsenic 5 in Aqueous Solution. Here is some simple introduction. Arsenic is a worthless byproduct from the natural process and anthropogenic activities. Arsenic contamination in soil and water is commonly found in many countries. As we can see from the picture above, over 200 million people globally drink arsenic-contaminated water at unsafe levels. Bone char is an useful method to utilize the waste, especially bones, from the meat production industry. Proceed to problem statements. Groundwater with high arsenic concentration through leaching of acid mine drainage and untreated acid wastewater is used for crops, irrigation and drinking water. Arsenic 5, a type of inorganic arsenic which is very stable in oxidative state, are mostly found in natural water systems, for example groundwater and surface water. An estimated 60 million tons of meat waste is produced yearly in Europe, and the waste has been utilized as bone char. This bone char has been used as fertilizers or adsorbents to remove fluorides, estradiol, or other elements in the water. However, there is a lack of relevant studies about metal-coated carbon char on remediation of arsenic-contaminated water. A NIBC analysis has been conducted from the previous studies. The need is to require effective, environmental friendly and low-cost remediation solution for arsenic contamination. The approach is by conversion of food waste to green adsorbent and simple adsorption application. The benefits are high availability and providing low-cost and environmental friendly alternative treatment techniques. The only challenge is the lack of accessibility to relevant preparation techniques. The objectives are to determine the optimum parameters of the removal of arsenic 5 by aluminium oxide coated carbon char under batch mode, and to ascertain the arsenic 5 removal efficiency of aluminium oxide coated carbon char. The research questions are: how do the parameters optimize the removal of arsenic 5 by aluminium oxide coated carbon char under batch mode, and what is the arsenic 5 removal efficiency of aluminium oxide coated carbon char? The significance of studies. First is the food waste utilization. The bone char has provided an alternative option for existing arsenic treatment techniques by transforming food waste to green and low-cost adsorbent without creating any disturbance to the environment. Besides, it also aims to achieve Sustainable Development Goals, the SDGs. Goal 12, the responsible consumption and production by encouraging waste reduction and eco-friendly production from waste, and Goal 6, clean water and sanitation by providing alternative techniques for remediation of arsenic-contaminated water. Some literature review has been done. Arsenic can occur through anthropogenic activities or naturally. Ingestion of arsenic may lead to severe health problems. Arsenic contamination in groundwater, wells, and public water supplies have been a serious issue in several countries. Bone char has a pure composition, good hydraulic conductivity, ability to neutralize pH, remove metallic elements and metalloids. Meanwhile, cow bone char has the lowest pore volume, ash content, moisture content, and high fixed carbon, which indicates its greater adsorption ability. Metal coatings have been used to provide larger surface area for adsorption process. This is my research framework. As for the preparation aspect, detailed background, problem, literature review, aim, methodology, and contribution of research have been done, followed by preliminary cleaning of apparatus. As for the measurement aspects, the preparation of adsorbent and adsorbate, followed by physical-chemical properties determination using XRD, EDS, and SEM instruments, batch adsorption experiments on contact time, adsorbent size, pH, adsorbent dosage, and adsorbate concentration, followed by instrumental analysis using ICP-MS. The preparation of adsorbent, which is the aluminum oxide coated cow bone char, involves certain process. First, the bone char will be cleaned to remove grease, remaining proteins and fats. After that, the bones will undergo pyrolysis at 750 degrees Celsius for 2 hours to provide larger surface area. The bone char will then be grounded and sieved into smaller size to ensure it has a good hydraulic conductivity for adsorption process. After that, the bone char will undergo carbon activation process using hydrochloric acid and metal coating process using aluminum trichloride hexahydrate solution. This is the experiment flow. 10 grams of 3 different sizes adsorbent will be weighed. 100 milliliter of 10 mg per liter arsenic 5 solution will be measured. The pH of the solution will be adjusted to pH 4 using 5% nitric acid. The adsorbent will then be added to the adsorbate and agitated at 150 rate per minute for 12 hours, and it will be homogenized at every interval of 2 hours. The sample collected will be sent to ICP-MS analysis, followed by data analysis. This experiment flow is based on the first batch experiment. The flow of second, third, and fourth batch experiment will be modified according to different parameters. There are 4 batch studies will be conducted. The first batch studies will be conducted to determine the adsorbent size and contact time. The second batch studies will be conducted using different pH 3, 4, 5, and 6, using predetermined parameters which are the adsorbent size and contact time. The third batch experiment will be conducted at different adsorbent dosage 5, 10, 15, 20, and 25 grams, using predetermined parameters which are the adsorbent size, contact time, and pH. The fourth batch experiments will be conducted at different adsorbate dosage, adsorbate concentration, which is 0.5, 1, 5, 10, and 20 mg per liter arsenic 5 solution, using predetermined adsorbent size, contact time, pH, and adsorbent dosage. The expected outcome. Aluminum oxide coated cow bone char is expected to reduce arsenic concentration in aqueous solution effectively and have high adsorbing capacity and recovery rate. It can be a potential adsorbent to be applied in wastewater treatment facilities. The research milestones. The research activities that will be conducted are the preparation of aluminum oxide coated cow bone char and arsenic 5 stock solutions, followed by conducting batch experiments and data analysis. The plan to complete the work is all the preparation of materials and apparatus must be done before August to proceed with batch studies which will take around 2 months. This is my Gantt chart and research milestones. Due to MCO, the preparation of materials and apparatus will start from June to July. And this is my list of reference. And that's all from me. Thank you.